Good morning, all of you. Today we will see the pure substances. We know that pure substances are classified into two, elements and compounds. What are elements? What are compounds? Today we will see the details of elements. Elements, the definition of element goes like this. That is, it is the basic or simplest form of matter which cannot be further divided by any physical or chemical means. It is the basic or simplest form of matter. But afterwards, when Dalton's atomic theory came, Dalton said this element can be further divided into atoms. He said atoms. And again, afterwards, atom was also further divided to electrons, protons, neutrons. So now we can say element is a pure substance made up of one kind of particles. Element is a pure substance made up of one kind of particles. You can write any one of this definition. Element is the basic form or the simplest form of matter that cannot be further divided, that cannot be further broken into simpler substances by physical or chemical means. That definition you can write. Or element is a pure substance. Element is a pure substance that consists of only one kind of particles. That also you can write, no problem. Means it is a basic form of matter. There are so many elements. This universe contains mainly hydrogen and helium. 92% is hydrogen in this universe and 7% is helium. Rest all elements together contribute 1%. Means oxygen, nitrogen, carbon dioxide, iron, aluminium, magnesium, sodium, lithium. So many elements, carbon, phosphorus, sulfur, so many elements. They all together constitute only 1%. So 92% of this universe is hydrogen, 7% is helium, rest all together make that 1%. Now coming to our nature. Coming to our nature, how many elements are known to us? 118, 118. If you almost 118 elements are known to us. In that, 92 are present in our nature. 92 elements are present in our nature. In that 92 elements, 70 elements 70 elements come to under the category metals. 70 elements come to under the category metals. Other type of elements, that is non-metal. Another type of element, metalloids. So these elements are classified into three: metals, non-metals, NON, non-metals, and metalloids. Metals. What are the properties of metals? Metals, iron is a metal. See, one piece of iron. Iron is a metal. In this, only one kind of particles are there. Iron atoms, iron atoms, iron atoms. So many iron atoms are closely packed, tightly packed to make this metal rod. This is iron metal. This is a metal. Then copper metal. This is copper metal. This is copper wire. This is copper metal. Then this is aluminium. Aluminium metal. Aluminium foil. The sound what you are hearing is called sonorous. The sound what you are calling, that is when it is bent. See, This tingling voice that is called. See, this tingling voice. This is sonorous. When I crush it or bend it or hit it, hit it. So this sound is sonorous. This can be this metal is made into a sheet, right? It was made into a sheet. I crumbled it. So the sound what you are hearing is sonorous, that is a property of metal, or this this metal, the sound is sonorous. These are the properties of these metals. So elements are classified into metals, non-metals, and metalloids. Non-metals, oxygen, nitrogen. Non-metal, the word itself shows that it is not metallic. Sulfur, carbon, these are non-metals. Let's see the classification of elements, what are the properties of these elements, etc. So pure substances are classified into elements and compounds. Elements and compounds. We are going to the details of elements. Elements are classified into metals, non-metals, and metalloids. Element definition, we said an element is the simplest or basic form of a pure substance which cannot be broken into anything simpler than it by physical or chemical methods. Later, studies by Dalton have shown that the simplest form of matter is atom. So, the above definition, what I said, has no relevance. In the light of this, the definition of an element can be modified in this form. What? An element may be defined as the pure substance which is made up of one kind of particles, one kind of atoms only, one kind of atoms only, or one kind of molecules only. Generally, we can say one kind of particles. Okay, we are moving to elements. In that classification, metals, non-metals, metalloids. Common examples of elements are hydrogen, carbon, oxygen, nitrogen, sulfur, copper, silver, gold. Note that these elements are the building blocks from which the entire universe is made. How many elements are known to us now? Although nearly 118 elements are known, the universe is made up of two. What are they mainly? That is 92% hydrogen and 7% helium, and rest all constitute 1%. Out of this known elements, 92 have been found in nature elements in nature? In nature, 92 elements are there. The rest have been synthesized by the scientists in the laboratory, or we call them man made elements. The man made elements are also known as synthetic elements. Earth is a major source of elements. These are distributed in different parts of the earth. These elements are distributed in different parts of the earth, known as atmosphere, hydrosphere, and lithosphere. Forget about those parts and all. So, here we have 92 elements in nature. We have already mentioned that about 92 elements have been found in nature. Rest all are man-made elements. Man-made elements are also called synthetic elements. Now, we are coming to the types of elements. First one is metal. Among these 92 elements, what we see in nature, we call it as naturally occurring. Out of this, nearly 70 elements are metal. 70 elements. 70 elements are metal out of this 92. Out of 92 naturally occurring, out of 92 metals which are naturally occurring, 70 elements are metals. In the metals, atoms are very closely packed together and have special types of attraction called metallic bonds. That attraction is called metallic bond. Metallic bond, you will be studying about this metallic bond in higher classes. Metallic bond. Because of very tight or close packing, very closely packed, these metals are quite hard. Now we are moving to the details of these metals. After that, we'll be moving to this non-metals, then metalloids. Coming to the details of metals. Metals are solids at room temperature. Metals are solids at room temperature. Exception is there. Mercury is a liquid. Mercury is a liquid at room temperature. Exception. Questions will be coming from the exceptions. Mercury. Which metal is a liquid at room temperature? The question comes like this. Which metal? Metals are generally solids. So the question is what? Which metal is a liquid at room temperature? Mercury is a liquid. At room temperature. And gallium and cesium. Gallium and cesium. Gallium and cesium become liquid at a temperature slightly above room temperature. If you put little gallium in your palm, if you put little gallium or cesium in your palm, then you will see it is melting. So gallium and cesium become become liquid at a temperature slightly above the room temperature. That is 303 Kelvin. 303 Kelvin means 30 degrees Celsius. So metals are solid at room temperature. Exception is the mercury is a liquid at room temperature. Now, number two. Metals have shining surfaces. Metals have shining surfaces. Means we say they have luster. They have luster. 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 Generally, they are silvery gray or golden yellow. They have generally silvery gray or golden yellow surfaces. So this shining property that property is called luster. I showed you aluminium. It has got a shining surface, luster. Gold has got shining surface. We say luster. Then iron has got, silver has got shining surface, that is luster. Number three, they are good conductors of heat and electricity. They are good conductors of heat and electricity. I showed you the copper wire, the wire with which we use this wiring inside our house to carry electricity, to carry current. So they are good conductors of heat and electricity. You can, if you heat one end of this wire and the other end will get heated, means that the other end will become hot. That means they are good conductors. They are the carriers of electricity. They are the carriers of heat, or we can say they are the good conductors, carrier of electricity or carrier of heat. We say conductor. They are good conductors of heat and electricity. Number 4, metals are generally quite hard. Metals are generally quite hard. Iron is hard, gold is hard, copper is hard, but some metals are soft, very soft. So here there is exception. Exception. Sodium and potassium are soft metals. Metals like sodium and potassium are soft. Sodium, one piece of sodium, that it looks like a paneer piece only. With a knife you can cut it, just like you are cutting a paneer. You can cut this sodium, metallic sodium, one piece of metallic sodium. See, one piece of metallic sodium, you can cut it with a knife. We can cut it into two parts. Suppose this is one piece of metallic sodium. With a knife you can cut it. So metals like sodium and potassium are very soft. Number 5. Metals are malleable in nature. Metals are malleable in nature means you can beat them into sheets. You can beat them into sheets, foils, aluminium foil. I showed you the aluminium foil. What is meant by the term malleable? They can be beaten to form very fine thin sheets. Beaten to form thin sheets. Thin sheets. You know, aluminum foils are used for wrapping different types of foods. Similarly, thin foils of silver are used for decorating sweets. Sweets, you see, that kaju, katli, and all are decorated by thin sheets of silver, thin layer of silver. Number 6. Metals are ductile in nature. Metals are ductile in nature. Metals are ductile in nature means it means that very fine and thin wires, WIRES, thin wires can be drawn from the metal. All electric wires drawn from different metals are very fine, very fine. This copper wire I showed you, copper wire. Then aluminium wires are there. Aluminium wires are there. Silver is the best conductor. Silver is the best conductor. So these can be drawn into wires. Gold can be drawn into wires. Thin wires are made to make these ornaments. Thin wires from 1 gram from 1 gram gold, you can draw a wire of almost very long wire can be made. Very thin wire can be made from very small amount of gold. Means we say they are ductile in nature. Means very fine and thin wires can be drawn from metals. We say ductile. Next point, metals are sonorous. Metals are sonorous. Point number 7. Metals are sonorous. What is meant by sonorous? That means that when they are bent or hit, they produce a tingling sound. That is, when hit or bent they produce a tingling sound. A tingling sound. Write these things in your copy. Tingling sound. Number 8. Metals have generally high melting and boiling point. Metals have generally high melting and boiling points. Why? Because these particles are closely or tightly packed. The force of attraction between the particles is very high, means you have to supply heat energy to break this force of attraction between the particles and make them separate. If it is solid, you have to heat them. You have to give heat energy to break the force of attraction between the particles so that from the solid state they fall to the liquid state. Now, what are the examples? Examples. A very a few commonly used metals are copper. Copper wire, I showed you copper, silver, silver for the ornaments, silver or the plates, gold. Again for ornaments, aluminium. Aluminium is a lightweight metal, that's why it is used to make the body of aeroplanes. Aluminium, aluminium, and aluminium tin foils can be made, aluminium wires can be made, iron, iron or iron, which is used to make vessels. Iron wires are there. Many instruments are made up of iron. Bridges are made up of iron. Then sodium. Sodium is an element which is present in our body also, which is required for the proper functioning of our body. Then potassium. Potassium is again present in our body, this element. Calcium in our teeth, calcium element, calcium is in our teeth. Then magnesium, magnesium, it is present in chlorophyll, chlorophyll in the leaves. Mercury is a metal which is used in thermometers. Mercury is used in thermometers. Then mercury has got silvery white color. It is a silver, you must have seen in the thermometer. Now, among the metals, aluminum is the most abundant in Earth's crust. Earth's crust, the most abundant is most abundant is aluminium, Al. We represent aluminium by Al. Iron, calcium, and sodium are the other metals which follow aluminium in order of decreasing abundance. Apart from Earth, there are other sources from where the metals can be obtained. For example, what I said, magnesium is present in chlorophyll. Magnesium, Mg. Magnesium is present in chlorophyll. You know chlorophyll? With which the leaves make their food, chlorophyll. Now, iron is a constituent. Iron is present in hemoglobin, in our blood, present in hemoglobin. Hemoglobin in our blood. Whereas zinc is found to be present in traces in the ice of certain elements. So, see the presence of metals in different parts, different in various fields. Magnesium is present in chlorophyll. So, magnesium is required for our food. These plants are making food for us. So, with the help of chlorophyll, these leaves are making food. Now, iron is a constant of hemoglobin, and zinc, I represent the zinc by Zn. Zinc is represented by Zn. Zinc. Zinc is present in traces in the ice of certain elements. C is also a source of different metals. C is a source of different metals like sodium, potassium, calcium, and magnesium. The salty nature of that water, sea water, that is due to the sodium chloride, potassium chloride, etc. So these are present in seawater as soluble salts, mostly halides, for example, sodium chloride. Sodium is present in the form of sodium chloride in seawater. That's why that salty taste. If you taste seawater, it is salty. So that's about metals. So generally, metals are quite hard. Elements are classified into metals, non-metals, and metalloids. Elements are classified into metals, non-metals, and metalloids. Metals are solids at room temperature. There is exception mercury. Thermometer. In thermometer you see the mercury. Mercury is a metal but it is in the liquid format. Metals have shining surfaces. Metals are good conductors of heat and electricity. They are malleable. They are sonorous. They are ductile. They are good conductors of heat and electricity. So in Earth's crust, if you in Earth's crust, maximum amount metals in Earth's crust. Maximum is aluminium. This much is aluminium. Then iron. Then calcium. Then sodium. Aluminium. Then iron. Then calcium. Then sodium. Then sodium. Then potassium. Then magnesium. Then others. So this gives you somewhat idea. My point is only to show the aluminium portion greater. The maximum amount is aluminium. Okay, that's about metals. Their properties you have to learn. Exceptions you have to learn. Uh, what is meant by metal? What is meant by metal? How many metals are there? 92. Out of this 92 elements, 70 elements are metals. Next is non-metals. Non-metals means they have got the properties opposite to that of metals. So about non-metals, we'll be learning in the next class. Thank you.